This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
Fundamental physics is currently facing a crisis of scale. The mathematical tools used to describe subatomic particles and cosmic gravity remain incompatible, leaving the laws of nature fractured. For decades, string theory was the primary candidate for unification. It proposed that every particle in the universe was actually a tiny, vibrating filament of energy. The framework began in 1968, when the Veneziano amplitudes were used to model the strong nuclear force as a physical string. By the mid-90s, Edward Witten achieved a massive synthesis, merging 5 competing string theories into a single 11-dimensional framework called M-theory. Shortly after, Juan Maldacena introduced holographic projection, suggesting that the geometry of a volume could be entirely described by the information on its boundary. However, this consistency relied on the existence of extraspatial dimensions, physical directions that no experiment has ever detected. This led to the landscape problem. The theory allows for 10 to the 500th possible configurations of these dimensions, each describing a different universe, with no way to determine which one is ours. Without a method to select a specific vacuum, the theory cannot make testable predictions. It remains a mathematical model that lacks a path to empirical validation. To move past this deadlock, we apply the Pasev closure of string theory, or PCST, a reduction protocol designed to extract the verifiable core of the framework. The PCST operator functions as a mathematical filter. It isolates the minimal structure needed for predictive power, stripping away hidden spatial dimensions and treating them as mathematical artifacts rather than physical realities. Those 10 or 11 dimensions are remapped, collapsing into internal spectral degrees of freedom, the frequencies and amplitudes that define the state of a local point. This shift changes the definition of a string. We no longer view it as a fundamental, one-dimensional object stretching through space. Instead, a string is the continuous trace, the observed pattern, created by a deeper, discrete architecture. This foundational layer is the Fabricon substrate, an observer-indexed network of individual geometric cells. By closing the theory, abstract strings are transformed into the measurable exhaust of these discrete cells. The Fabricon is the irreducible unit of this new reality. Each Fabricon cell has 2 components: an identity kernel indexing the observer, and a boundary interface governing adjacent interactions. Internally, the system tracks the structural trace and spectral field. These cells link at their boundaries, forming a continuous, stable microfabric. The strings we observe in high-energy physics are coherent waves of information traveling across this interconnected Fabricon mesh. This architecture forces a rethink of the space-time metric, the G-tensor that defines gravity. The metric is not a pre-existing background container. It is induced by the geometric connectivity of the Fabricon cells. If the geometry of space is a result of cell connectivity, then curvature can be treated as a local variable. We aren't moving through a passive vacuum. We inhabit a structural fabric, where curvature can be programmed through spectral modulation. To verify this relationship between spectral fields and curvature, the model must be encoded into a formal proof system. We use the Lean-4 environment to check the mathematical logic of the Fabricon substrate. This ensures the theory is internally consistent before we ever move to the lab. The master equation compiles in Lean-4, confirming stable closure. The Polyakov string action reduces term for term directly into the Fabricon trace action. This compilation enforces the omega laws, invariants that prevent the system from collapsing or violating the conservation of energy. By analyzing the induced metric within this proven kernel, the equations for general relativity emerge. The Ricci curvature tensor is recovered from the geometric connectivity of the cells. Simultaneously, the gauge structures required for electromagnetism and quantum field theory project from the spectral field's internal variables. Because these forces share the same Fabricon substrate, the proof identifies a precise mechanism, using a spectral field to engineer local spacetime curvature. We move from code to hardware with the TD1 demonstrator. This is the first physical test of the cross-layer coupling predicted by the proof. The goal is to determine if modulating a spectral field can generate a directional force without expelling mass. The core of the system is a resonant cavity machined from high-purity copper. The internal geometry of this cavity is intentionally asymmetric. This asymmetry is calculated to provide a non-uniform boundary for the internal field. Energy is supplied by dual RF signal generators, which are phase-locked to maintain a constant timing relationship. We inject specific radio frequencies into the cavity, creating a controlled electromagnetic environment. By shifting the phase between these signals, we force a nonlinear interaction with the cavity's asymmetric boundary. This phase imbalance modulates the local boundary conditions of the underlying Fabricon substrate. As predicted, this creates a curvature gradient in the vacuum immediately surrounding the hardware. The force equation derived from the Lean-4 proof predicts that the output will be phase-dependent. The force should follow a sine wave relative to the phase shift between the RF sources. If successful, the TD1 hardware achieves force through pure vacuum curvature, a propulsion mechanism that requires no propellant. Empirical data from the first campaign reveals a clear force signature. The reading rises significantly above the noise floor, confirming the coupling between the RF phase and the substrate. The force is phase reversible. When we shift the signal phase by 180 degrees, the force direction inverts exactly, which rules out thermal drift or vibrational noise as the source. This means we can generate acceleration without carrying or expelling chemical mass. These TD1 units are modular. We can industrialize the production of the resonant cavities and the phase control electronics. By networking these modules into coordinated arrays, we can scale the total thrust and provide 3-axis vector control. In practice, this allows for persistent orbital station keeping and deep space transit without the weight penalty of traditional fuel. String theory has been successfully closed. The abstract mathematics of the worldsheet have been reduced to a set of actionable engineering principles. We are no longer limited by the mass we can carry.
This video
By
presents
engineering the
declassified
curvature
and
of
licensed
space
material
itself,
of the Global
we have
Institute
moved
of
into
Logic
a
and
new era of
Cybernetics.
propulsion and strategic autonomy.